Now let's talk about the next problem on the board, and before I can do that, you need to know something about normal shift. What exactly is this? See, when you have any denser medium and you have a light source and anything kept inside the denser medium, light would travel like this, and I know that from denser to rarer medium, light would actually bend away from the normal. So once it is refracted, it bends away from the normal. For me, for anyone who's looking at the light coming up, they can only see that light is coming in this direction. Alright, so in fact they would see a body which is kept here. In fact, the body is here, right? So there is a shift in the position of virtual shift. It means it is not a real shift, but I can see the body to be here. This is called as normal shift. Very simple. Now we need to understand on what parameters does normal shift depend on, and I see that the formula of normal shift says t in 1 minus 1 by n. That's it. Alright, and that formula I have t and n. That is only two things. It means normal shift only depends on the thickness of the material and the refractive index of the material. That is it. Now why am I talking about this? Simply because if at all I see the same body from three different angles, the angle of incidence does not really matter. From wherever I see, it doesn't really matter. Look at this diagram. If at all I see the light, this body from this direction, I can see that actually light from here is going in all directions. I'm just taking three directions here. When light goes from here, this person would see the shift at the same height. There's the same height, and from the same body is another ray of light which is traveling like this, and for someone who's seeing here would see the body in the same height, right? The only thing changes is the angle of incidence is more and refraction is more, but all of them, whether it's this guy or this guy or this guy or whatever direction you see, or you actually come here and see right from the top, still you see the body raised up to the same height. Okay, so normal shift does not really depend on from where we see the body, right? So this diagram simply explains that. Simply understand the only two criteria to find out the normal shift is the thickness of the body and the refractive index of the body. Alright, now let's do this problem and see how it works. Now we just understood something about normal shift, and now let's apply the same logic onto this problem and see how it works. The first logic we need to follow is to draw the diagram. Remember that drawing the diagram and writing the given data is part of your solving problem. So it says a tank contains a slab of glass 5 centimeters thick. Let's say this is a slab of 5 centimeters thick, 5 centimeters, and of refractive index 1.5. Let's say n is equal to 1.5. Cool. The next thing is placed at its bottom. Above this slab, a layer of liquid. It means above this slab there is another layer of liquid. Okay, that's a liquid of refractive index 1.4 is poured to it about 4 centimeters. So I can say this guy is 4 centimeters and the refractive index is again 1.4. What is the next thing? It says above this liquid there is a 6 centimeter water. Alright, so above this you have 6 centimeters of water basically poured, 6 centimeters, and the refractive index is 4 by 3. Alright, so we have this information given, and what is the total normal shift? Alright, now we understand this. So normal shift does not depend on for what angle I see. So I don't matter. It doesn't really matter from where I see. Right. So only thing what matters is what is the shift in this guy, what is the shift in this guy, and what is the shift in this guy. If I calculate the shift in all the three things and I add it up, I get the total shift. So let's go with one by one. Simple problem is. So let's talk about the shift in the first thing. Okay. So this is called as N1 here, and N2 here, and N3 here. And the total shift will be NS will be N1 plus N2 plus N3. That's the whole problem. It's a very simple problem and sometimes asks 5 marks. Alright, so how do you calculate N1? Go back to the formulas, you know that it is T into 1 minus 1 by N. That is it. So what is the thickness of the first slide? It is 5 centimeters. So I can write 5 into 1 minus 1 by. What is the refractive index given to you? It is 1.5. So 1.5. Can you calculate N1? That is 5 into, that is 1.5 minus 1 over 1.5. That should be 5 into 0.5 over 1.5. That's what you have. So if I solve this value, I'll get 1.67. Please solve this yourself using a calci. Alright. So what is the next shift? Next, about this guy. So let's talk about N2. N2 is again given by T in 1 minus 1 by N. Now who's T here? T is the thickness of the second layer. That should be 4 centimeters into 1 minus 1 by 1.4. So 4 into, I take the LCM again, is 1.4. 1.4 minus 1, that should be 4 into 0.4 by 1.4. Okay, I solve this guy, I get a value of 1.41. That is 1.14 centimeters. Okay, cool. That is N2. Let's come back to the third guy, that is N3. N3 is again the third layer here. It is like 6 into 1 minus 1 by 4 by 3. Okay, let's solve this guy, see how it works. That is 6 into 1 minus, I can put this 3 up, that becomes 3 by 4. It is 1 minus 3 by 4 is simply 1 by 4. Alright, 1 minus 3, 4, that's 1 4. Very simple. I solve this guy, I get a value of 1.5 centimeters. So I see that N3 is 1.5 centimeters. So what we have to do in this problem is, for every different layer, you got to calculate the shift. And the total shift will be the sum of all the shifts. It's a very, very simple problem after 5 marks. Do not miss this logic at least, and it doesn't have anything difficult, so you'll also. Alright? Now, what is the total shift? Total shift can be given as N1 plus N2 plus N3. That should be equal to 1.67 plus 1.14 is 1.15. Alright, 1.5. That's it. So if you calculate this, it goes to be 4.31 centimeters. And that is it. So that is the total shift. Okay? Now, he's asking another thing, and hence calculate the apparent depth. Apparent depth is what exactly? Let's say this was the coin I was looking for. It shifted so much from this guy, and let's say N1 is here, N2 is here, and N3 is here. Overall shift, let's say this body was here. So in sense, the overall shift is 4.3. It means somewhere here, it will be like 4.3. This is the normal shift. Okay, this is the complete shift. This guy is N1 plus N2 plus N3. So this, what is the apparent depth? Is this height. Okay, so what is the apparent depth? It is basically this height is the apparent depth, and this guy is the real depth. See, if at all I take the real depth and I subtract the normal shift, what do I get? I get what is the apparent depth. So let us make a formula here. It says apparent depth can be given as the real depth minus normal shift. That's all about it. So what is the real depth of the whole thing? It is 5 centimeters here, and 4 centimeters here, and 6 centimeters. That should be 10 and 15. So this is 15 minus, so I got it as 4.31 normal shift, and if I solve this, I'll get 10.69 centimeters. Okay, this is the apparent depth, or I see the object which is lying in sight, the bottom at the height of 10.69. Okay, which is supposed to be the apparent depth. That's a very simple problem. Try doing more problems on the same type from your textbooks and see how it works.